you ready? This one's to flow. Right. So, the experiment we're doing is we are going to look at the effect of height on GPE, gravitational potential energy. Yep. So what you're going to do in your prac is that you've got some sort of maybe retort stand or something. All right. And we have a ruler. So we're going to have a little flag going out there. I'm going to say this is a ruler. Okay. Down the bottom here, you're going to have a bucket of sand. Yeah. And then you're going to have a ball bearing that you're going to drop. Yep. So everybody do it? Yep. In the test.
In the practical.
Yes, in the investigation.
Will we have a scale to weigh?
I'll weigh the ball bearing. Now we'll say here, how much we'll say the ball bearing weighs 100 grams, okay? Shall we do it here? Ball bearing here, which will weigh today, we'll call it 100 grams. Yes?
In the scientific diagram,
Yes.
you
draw it as it is set up. You don't draw the individual bits.
So you don't include the ball bearing?
Of course you're going to include the ball bearing.
Just on the ground?
Oh, you can just draw it here because it's about to drop.
Where would you put the magnet?
All right, I'll explain about the magnet in a minute.
For like the title, it's the effect of the height on the GPE, not on the size of the crate.
Yes, because you measure. Well, you're trying. I think it's talking about you're trying to calculate the GPE, but you're trying to get an indication of the GPE by the size of the crater. So, although you're measuring the size of the crater, what you're actually looking for is the changes in the GPE, because the more force that it hits with, it's going to splatter more.
So the same in the hypothesis.
It's all about. I'd say it's all about GPE.
Okay.
Yes.
Are we calculating the GPE?
I'm about to do it right now. Okay. So let's go through. That's the setup. So essentially, you're going to be dropping the ball bearing from various heights as you go up, and from each height, you want to do it at least 3 times. Yep. So the things that we need to get right, we need the independent variable, the dependent variable, the controlled variables, and we want to talk about the hypothesis. So the independent variable is what we are changing, and we are changing the height from which the ball bearing is dropped. Height of ball bearing drop. Okay, and that's going to be in centimeters. Yes.
Is there a certain height you recommend going up by?
Tens? Depends on how much time you've got. If it's going to be 5s, it's going to be there for a long time. So 10s is fine. All we need to do is get a trend, and that will give us the result. We already know what the result's going to be.
And how many different heights should we drop it from?
Oh, it doesn't take long to drop a ball bearing. So you can do, because your control experiment, which we'll get to in a minute, you could go 10 centimeters, 20 centimeters, 30 centimeters, 40 centimeters, 50 centimeters. That will give you enough data. Yeah, it depends on how high you want to go up and how bored you can afford to get. All right, there's only so many times you can drop a ball bearing. Unless you flow, then she'll probably do it all day, every day. Yeah, it's you do as many as you want.
Okay.
Right. Okay? The dependent variable is what you're measuring. So you're going to measure the size of the crater.
Mr. Kelly, depth or size?
Sorry?
Depth or size?
It's up to you. You could measure both if you wanted to. Depth would be fine. Depth would give you a better result than.
But isn't like the point of the skewer to measure the depth?
Yeah.
So
Well, it's up to you what you. It's up to you how you want to measure it. I would measure the depth because it'll get deeper and deeper and deeper and deeper the more GPE that it does have.
So the
But sorry,
the
dependent variable is the depth of the crater.
So it's not the gravitational.
Well, I said size, but it could be depth. Yep.
But then you said
But then what?
the effect of the height on the.
Yes, I know because this will get bigger. The depth.
But are we getting a number for the GPE, or is it just the number?
Yes, I'm getting there. I'm getting there. The depth of the crater then. Okay? You measure it with your stick, right? You get the ball bearing out with your magnet. So when it hits, it leaves a little dent. Boop. Right? Looks like I've landed on the sand. Okay? You've got your ball bearing in there. And then so you don't destroy the crater with your big sausage fingers, you get the magnet and you hold it and so here's your magnet and it'll stick to the ball bearing. Okay, and then you can play with your paddle pop stick or whatever. All right, and then you can measure it. Yeah. Right. When it comes, now this is an indication of GPE. Okay? Because the higher the amount of GPE, the more damage it's going to do to the sand. Yeah?
In the table that we draw up, in brackets do we put GPE, and that's what we.
Because what you're going to be measuring is the depth, and then what we're going to do is talk about the relationship between GPE and the depth. The dependent variable is what you measure.
Yes. But for the table, see here, I wrote height and we measure the height in centimeters. Do we write the depth here or the GPE?
You're measuring the depth of the crater.
So what is the unit?
The dependent variable is depth, millimeters. Millimeters. Sorry, I was trying to use English, which obviously isn't your first language. All right, millimeters. Okay? Right, I'm glad we got there.
Yeah, me too.
Right. Does Mr. Cotter ever floss for you?
No.
Oh, okay. I can see you were thinking there, gee, I'd like to see that. Right? That's okay. It's okay. Yes,
Do we just put another column in the table?
if you want to, but it's more about, because at here, you could, instead of writing that, you could write depth of crater. Okay? Knowing that that is an indicator of the GPE. Because I think on the sheet that they've given you to write it up, it talks about GPE. Right? So we just need a way to measure impact. Okay? And the bigger the GPE, the bigger impact you're going to get because of LOCO. Do you remember what LOCO is? Law of Conservation of Energy?
Yep.
Right?
Okay.
Yep. Uh-huh. Yep. Right. Right. It's when you get out to what the diameter of the ball bearing is, even if it goes down further, the diameter will still be the same. Not a bit, because you're going to wet the sand, and it's going to be easier to measure with damp sand. And that means after every time it's dropped, Flo, this is what you like to do, smooth out the sand again every time. That's what you do. When you're at the beach, when you dig a hole, don't you then smooth out the sand again? or just leave that big hole
You
there.
have to make a sandcastle and then do a moat around it.
I know, but then at the end of the day, you smooth it all out
No,
again.
no, no. You have to wait till you come
Well,
back next time.
in
and
this
see what's
crack,
happening.
once the ball bearing's dropped, so you can do another experiment, you've got to smooth it all out again.
Yeah.
Try not to make sandcastles with your little bucket of sand. Okay?
Oh my gosh. Okay.
Right.
Control
All right, Tay Tay? Okay? So the hypothesis is what you think the effect of the independent variable is going to be on the dependent variable. And I'll tell you, as the height of the ball bearing drop increases, the depth of the crater will also increase. We're going to end up with a graph that looks pretty well similar to that. Okay? What result? What kind of result do we call that?
Linear.
It is, well done. It means it's a line, but what sort of linear is it? Such. It is positive, and I'm looking for a different word where that means as one goes up, the other goes up.
Oh,
It's sort of like what you do. It's sort of like what you do when someone's going to ask you to marry them,
you say yes.
huh? But it's slightly different than that because it's a different word.
You say no.
So if they propose to you, but it's not that word. This isn't a proposed. This is. Don't give me random words.
I suggest.
Right, shall I tell you what word I'm aiming for?
Yeah.
Proportional.
Is that what it is?
I was trying to get there. My next clue was about porpoises. So
I would've
relatively,
put that.
proposing was closer than a dolphin that's not a dolphin. Okay? So proportional means as one goes up, the other goes up. As the independent variable goes up, the dependent variable goes up, and the word we use there is proportional. All right, so the hypothesis is, as the height of the ball bearing drop increases, the depth of the crater increases. Okay?
We have to explain our hypothesis.
No? Controlled variables are the things that stay the same. So we need to think about what could influence what we're measuring. All right? Now, the important thing here is you write the same, and then you mention. So what could change the depth of the crater, but we don't want it to?
The same. Oh wait, no. Different diameter and weight of the ball.
The same
No, but
ball
you're
bearing.
Your question.
The same surface. Same surface that you're dropping, which is wet sand. The same. We try and stay away from people doing stuff. We try and make it about what the equipment is.
The
like
type of sand.
the type of sand. Yep.
Same gravity. Does that
Yeah,
count?
gravity stays the same because you're probably going to do it on Earth.
Not the moon.
Mostly, you're going to be on Earth. Are you angry, Flo?
It's like
Sorry?
that Florence helped.
What's wrong? What's wrong, Florence?
I'm gonna tell my mommy.
That's right. I'm recording it so you can see.
Why are you coming at me?
I'm not. I'm having a discussion with you. You don't like people discussing things with you.
No.
I only talk to people I like, so it must mean I like you.
Oh,
Right.
that's nice.
If I don't like you, I just don't talk to you.
Yeah.
Oh, okay. Well, I'm just joking. All right. Sorry? We try and stay away from people. All right? What you've got to try and do is make it about the equipment and about the process rather than about the person. Because although sometimes they let you get away with it in year 7, it's not really a valid source of error or controlled variable, because it's given that you will do what you can to make your experiment run properly. Yep. So we try and keep it about the equipment or the procedure.
The dropping method could be like you drop it by hand or you drop it by hand.
But you don't
Like you
throw
drop
it with
Okay, if you want to put down the same dropping method, you do that. All right. I'm going to say I'm going to bring in I'm going to go to my mum's business and I'm going to get, which is an auto cut, which is like a car wrecking place, where I'm going to get the big electromagnet and pick up the ball bearing and then switch it off and it's going to drop it. Yeah. Good.
The same amount of moisture in the sand.
Same wetness of sand. Yes. But that's going to be hard to do.
But what time of the exhaust pipe?
What?
What time of the
You think? Have you ever had a ball bearing absorb water?
I don't know what a ball bearing is.
Sorry? Has your mother never bought you a ball bearing? Maybe go home tonight and say, Mum, you know how my birthday's in like 6 weeks' time? Can you please buy me a ball bearing?
It's in 5 months.
Well, say, Mum, you know how my birthday's in 5 months? Can you buy me like an early birthday present? And she goes, yes, darling. And you go, all right, I'll have a ball bearing, thanks. All right? And you can take it with you everywhere. Imagine if you're walking down the street in the Claremont Quarter and a random person comes up to you and goes, hey, got a ball bearing? You'll go, yes, ta-da, I got it for my birthday. You'll be prepared. Yes.
I was just wondering, for like in our prep books, for like the discussion and
We're not even up to that yet.
do we
We're
do that
not
in
even
class
up to that
tonight,
yet.
or do we do
We're
that
not
after?
even up to that yet.
Okay.
Right.
You have to do it in
Yes.
class because you won't have the results.
Like after
Yeah,
the
but that
class.
really won't influence what you are
No, we don't hand it tomorrow.
measuring.
We hand it
Will it?
tomorrow.
I guess you get calipers. You've got calipers to measure the how far in the paddle pop stick. There's a little slidey scale on them.
What's a caliper?
What's a caliber?
They measure the size of small things. Yes.
Is the validation a week? Is it going to be like next week?
Yes, it's next week.
On Tuesday.
I don't know.
On Tuesday.
And is that when we hand in the crap?
Yes.
Oh,
Right.
okay.
And you wear school socks when you hand it in.
Yeah, I've got it.
And you make sure your hair's tied back in a bun.
What if I want to wear a ponytail?
Then space buns. Right. So now when we do the experiment, we want to make sure we have a control experiment. And we want to make sure we have a treatment group. The control experiment is when you don't have the independent variable. What is the independent variable, Flo?
The height.
Or am I coming at you too much? Ooh, gangster style.
Height of the ball drop.
Yeah, so what is zero height?
Zero.
Zero. So you measure the size of the crater with the ball bearing just lying on the sand.
Yeah.
Like they're on the beach in Bali. Hey, you can go to Bali and take your ball bearing with you and put it on the sand next to you. Right. So the control experiment is 0 centimeters in height. Okay? So what is the function of the control experiment? It's two things. Sorry? Yes, that's the second one. So there's two things. Basis of comparison. But the first one is, starts with B, doesn't end in all bearing,
Ball bearing.
doesn't end in all bearing.
Bruh.
Bro, did you just brought me?
No, I brought me.
Well, you should. This one starts with B and ends in ace line.
Baseline.
Yeah, it provides a baseline. Bro. Provides a baseline. Yes.
Do you include the control experiment when you're like putting it in the table?
Yes, the very first one should be 0 centimeters.
So then
You always have to have the control experiment first.
and is that on the graph as well?
Yes.
Why
Yes.
would it be like you'll put it in the sand and because it weighs it'll make like a little tiny
I don't know, will it? Will you be able to measure it?
So then you measure
I don't know, depending on how, if you just placed it there or did you place it down and give it a little press?
No, but if you just put it down, it's just weight.
I don't know. Well, it only weighs 100 grams. And it probably doesn't even weigh that much. Sorry?
Yeah, but sand has like air between it.
So then we'll press down so it's harder.
Wait. It will go down. Wait, so
All right, you will measure it. You will measure
Are
it.
you still measuring the indentation?
Correct. but there won't be an indentation.
What if
There
there is
is
an
an
indentation?
No, listen, I know people that've got indentations. I don't know either, but it sounds good.
I don't know. It's like a roast.
I don't know. It sounds like a good roast, doesn't it? Ha! You've got indentations. Ooh, ouch. My belly button. Ha ha!
What's wrong with having a belly button?
Everyone
I've got a. I'm just saying. It sounds like it's a good roast, but it's not meant to be. It just sounds good. Like it doesn't actually mean anything. Does it? Or maybe it does. But I don't think it does. But anyway, it sounds like it's a good roast. Don't you think? Ah! You could go home to what do you call him? Chris, and say, ha! You've got indentations. You go, what? You go, no, don't worry about it. And you just have it over him for like 30 years. And then like in 30 years' time, you'll be sitting down at his birthday when he's, I don't know, 45 years old and say, oh, by the way, that roast I gave you actually meant nothing. And he goes, oh, because that's really hung over me for the last 30 years. I wasn't sure what you were saying. And so I was just messing with you. All right? Right. But don't say Tim Mum. She might throw you outside with Benny and Jen and Jerry. Okay?
Benny. Wait, which one's the blue one?
Anyway, the treatment group is all the others. So that'll be 10, 20, 30, 40. Okay? That's with the independent variable. Yeah? Yes? No? No, yes? Right. So, now, are we ready to move on? I'm going to rub that off. No questions about what's on there?
When we put the treatment group the control experiment in the table, do we like write anything?
No, you just need to put 0, but know that it is the control experiment.
Okay. So
I'll draw the table for you. Okay. All right.
yeah.
Hi.
With the control experiment, like basis of comparison, in the discussion, do we have to talk
We'll get to that in a minute. At the moment, we're doing the table and the graph.
Yes.
Yep.
Yes.
Yep.
Yes.
We're not doing a flow. We're doing a
Oh.
floss.
I'm not a floss.
I know you're a flow. You're only half a floss. Okay. Right. So the table just needs to look like this. The table and the graph have the same title. Just buying some shoes, will you? Right. So this will be the effect of height, ball bearing height on crater size. Crater depth. Right, don't give me one on a raised eyebrow. I saw that. Now, when you do your table, I'll draw a little one here. That's what tables always look like. Yep. Yes.
So just confirm, that means that's our title for the whole thing and not
Who's
the
your- oh, who's over there?
height
Oh,
on
it's
the
somebody, yeah,
GPA.
you're over there.
So it's not GPA.
Who's your buddy? Don't have it here now. Yeah. Hey, who's over there?
Porciano, she has feelings of her.
Does she have feelings?
Yeah.
She might be a ball bearing. Do ball bearings have feelings?
I just wanted to prove that. So it can either be obviously sex gravitational energy or the ball bearing.
The effect of ball bearing height, drop height on crater depth.
So it's not gravitational attention.
No, but you could, right? And you wouldn't be wrong. You wouldn't be wrong. Okay? So. I'm surprised you know how to use technology.
Why?
Right. So this is where we put the independent variable. What was our independent variable?
Height.
Height of ball bearing drop. Right. And that was in
Centimeters.
centimeters. So here we'll go 0, 10, 20, 30, 40, 50. Here is trial 1, trial 2, trial 3, average. And here we write the dependent variable, which is depth of crater, and that's going to be in millimeters. Yeah? Ja, ja? 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 Ja, na.
Yeah.
Na, ja, ja. All right, so, and then we'll get numbers here, right? So if you get an outlier, and it's unlikely you'll get an outlier, you have to circle it and not include it in your average, yeah? And then you only graph the averages, yes? So you have 0, 10, 20, 30, 40, 50. Okay? Yeah?
And you do the
Did someone punch you? Did Miss Besant just give you a blood nose? She's like that.
do you do the GP,
We will in a minute. All right?
but not in the
We're going to try, we have to prove our results. So at the moment, we're just graphing the results, and then we're going to talk about what they mean in our discussion. All right? Yes.
When we're proving the results,
Yes.
are we calculating the
We
GPA?
are going to graph the results now, and then we're going to discuss them.
But is there any calculation?
We're going to graph the results now, and then we're going to discuss them. When are we going to discuss them?
In the discussion.
In a minute. In the discussion. Well done. Well done, Flo.
Thanks.
I have to help. Right. So it's the same title, which is the effect of. Got a bit aggressive there. The effect of ball bearing drop height on crater depth. Okay? The effect of ball bearing drop height on depth of crater. Okay? All good? Okay? Right. So here is our y-axis. Here's our x-axis. On the y-axis, we always put the dependent variable. So this will be depth of crater. All right? So this is in millimeters. Yep. And then we can go, I don't know, 0, 1, 2. I think you'd be lucky to get 3 millimeters. Oh, maybe you will. We'll have 4. All right? Yep. Yes.
How many decimal points should we
It depends on how much was in your data. If there was 1 decimal point in your data, then there'll be 1 decimal point significant figures.
And then should we go by like 0 point?
It's up to you.
So when you measure the what's it called?
When you measure,
The control experiment, so the one that starts on 0, would you just write that in like along the y-axis, like?
you just
Because
dot
the
it in
zero's on the
corner.
bottom.
yeah, no, it's on. It's a 0, 0. It's on both. It's a 0, 0. It's where the 2 lines meet. And this is drop height. This is ball bearing drop.
But do you write it
Height.
separately?
Sorry,
Do you write it separately, like underneath, or do you just do it there where it already says 0?
what are you talking about? I just wrote 0. You can put 1 0. I mean 0 for that way and 0 for that way.
Okay, and then you just put it there. Okay.
You could draw, if you really want to live on the edge, you could write 2 zeros. I know, but that's extreme. But you know what they say? If you're not living on the edge, you're taking up too much room. I know. Mum, I wrote 2 zeros. Okay? So here I'm going to have drop height 10, 20, 30, 40, 50. Yeah? Yeah. Oh, you tired?
Yeah.
Oh, dear. I guess sleeping with Benny and Jerry is really...
They sleep downstairs.
And?
They must sleep upstairs.
It's only because she accused her mum of having an indentation. Did you? Well, that's why you were sleeping down with the dogs.
Oh, I'm not sleeping. No.
Well, they sleep upstairs, you're sleeping downstairs. Right, so here we are. At 0, 0, we know that it's going to give us no no depth in the crater. Okay? And then we'll just make up some results. We'll say it goes like this. Okay? And then we've got to do a LOBFA. Line of best fit. So with a LOBFA, we've got to guess, we use a ruler and we do a line that represents the data. All right? Okay? We'll do a LOBFA. Yeah? So right here, this is the LOBFA, line of best fit.
Is that the trend in the data?
That is the trend. But it accounts for some of the variation in here. Okay? Because you're going to have things that are changed slightly every time, and by them doing the line of best fit, it allows you to account for some of the variation. All right? It doesn't have to go through every line. It doesn't have to go through the start and the end. It just has to represent the data. All right? And as long as it looks like it does, then you'll get away with doing it. Okay?
And it doesn't have to be straight.
It has to be straight because it's a line.
You have to use a ruler for it.
But I thought in the last.
If you don't have a ruler, ask Mum to buy you one when she goes to buy you a ball bearing.
I feel like swoop.
Yeah, there's one that goes.
Hang on, I have someone sneezing all over me.
What's the one where it goes? Ooh.
Yeah,
So it goes like
I
this.
took-
Is that
And it
just
goes like
in
that.
maths?
No, because it was in our test once, remember?
It
And everyone
was-
thought they got it wrong because they didn't do like a swoop in it.
Well,
Oh yeah, I got that one.
in this experiment, I would do a LOBFA that's nice and straight with a ruler.
And no curve at the end of it. What does the curve at the end of it mean?
That means.
Doesn't that mean
There'll
that
be
it
no curve
continues
because that means
on?
you'll end up with 2 data points. Okay? I would just keep it as a nice, beautiful, straight line. Okay? If this one here is lower than this one here, there is something dramatically wrong with your experiment. All right? Because normally, the higher you drop something from, it doesn't lose potential energy. Yeah? Yeah?
Yeah.
Right. So then you do your graph. Now comes the discussion. Uh-huh. This is where we're going to start doing our GPE. Ah. Right. Are you ready? Right. No, but are you ready? Are you ready?
Yeah.
Right. So, what we want to do here in our discussion is number 1. Yes.
In our method, do we include stuff about how to calculate GPE?
No. Okay, you think the method is just how to get your results. All right, you've got to make sure you have got lots of controlled variables though, because if you've got lots of controlled variables, what does that give you?
Do you write that in your
No, no, this is us just discussing why you have lots of controlled variables.
Validity or
Validity. All right, you have the more controlled variables you have gives your experiment more validity. All right, which means that you are measuring what you think you're measuring. So the only thing that you want to be changing is the independent variable. Everything else stays the same.
What's reliability then?
All right, now we get to reliability. This is why you do 3 trials to get consistent results. Right, so let's talk quickly before we get on to the discussion. Let's talk about validity and we'll talk about reliability. Okay? Validity is you getting your results actually mean something because the only thing that's being changed is your independent variable. Okay? And the way to improve validity, the way to improve it is to get more controlled variables. So you want to have the way to improve it is more controlled variables. It makes it more and more valid. Okay? All good? Do you have a ball bearing at home? No. Does anybody have a ball? You guys are missing out.
what even is? I would like. What is it?
What are we meant to do with it?
It's a ball
Is it the
of
same as a
steel.
marble?
Is it just like a circular?
It's a ball.
It's
It's a ball made of metal.
Really? No,
Correct.
this Murphy showed us it and it looks like a ring.
Not sure what
Oh, sorry.
planet you were on when that happened, but here on
Manual
Earth,
fluids.
a ball bearing is a ball made of metal.
Okay.
Right?
It's like a marble.
No, it's a ball made of metal.
It looks
Shape
like a
of
marble.
It's a shape of a
That's
marble,
all
but
I
it's
know.
actually made of metal.
It's
Oh,
like
that's
in a
what it
ring.
is.
But it's like those little
Flow.
balls.
We're not getting
Oh, it's one of the things.
Right.
Yeah.
Now, reliability.
But it's
Oh
like
yeah,
one
see,
of
oh,
the-
that's a ring. That's a ring.
No.
One of those.
The ball bearings allow it to spin.
One of those balls in.
We're only dropping one. Yeah.
Anyway, I'm going to
One
continue.
Okay. Yeah.
Maybe you can go and ask mother or father or grandmother. Excuse me, Nana or Pop. Can you buy me a ball bearing if your mother and father won't buy it for you? Right. So, reliability is trying to get the same result over and over again. Okay, trying to get consistent results. And the way to improve reliability is to increase your sample size or to repeat the experiment. They will both increase your reliability. Good? Sample size. You know how we did when we were doing the treatment experiment, we had 10, 20, 30, 40, 50? What you could have done to increase that sample size, you could have done 5, 10, 15, 20, 25, 30, 35, 40, 45, 50.
Yeah.
By putting more delineations in the independent variable, it makes your results more reliable. It means you can trust them more. All
So
good?
that would like for us. That would be if you were like increasing the height by 5
Yes,
centimeters
instead of
and
10.
did, like, a
Yeah.
lot.
Okay? And repeat the experiment is just doing it all over again. Yeah. So the discussion, we need to talk about the trend. What word did I use that sounded like the word porpoise? Proportional. Is that what you were going to say? Yes? Yes, that's what she was going to say. So we need to talk about the results are proporposeful. Porpoise.
What's the actual word, Mrs. Ryan? Proportional.
Proporposeful.
Thank you.
It means you are full of porpoises. Okay? It's proportional, which means that as you increase the height, you also increase the depth of the crater. Yes? Now we get to why. This is the thing you've been hanging out for. Uh-huh. Yes?
Yeah.
Now, we know that if you increase GPE, that's going to get converted into KE. All right? We know this, don't we? Because of LOCO, Law of Conservation of Energy. Yes? So as you increase GPE, you're going to increase KE, and when it hits the sand, it's going to translate that energy into movement of the sand, which is your depth. It's going to give you, due to friction, it's going to give you heat, light, and sound. Now, these ones here are all wasted energy. The one that you're looking at is the movement of the sand. Yep.
How light?
What's wrong?
How is it light energy?
Have you never seen a ball bearing hit some sand?
No.
It's like blinding.
What does LOCO stand for?
Sorry, I'm trying not to laugh. Sorry.
What does LOCO stand for?
Law of Conservation of Energy. Because it comes from one of my favourite scientists of all time, Lavoisier. But we can't just say Lavoisier. We have to say, Lavoisier. You can't just say Lavoisier without the first. Anyone here speak French?
I used to do French.
All right, you ever say, whenever you say anything, you go,
Like when?
Lavoisier. No? Like, baguette.
Yes.
Yeah.
Yes.
Escargot.
I had those. They're really gross.
That's a snail.
Yeah, I know. They're really bad.
Are they?
Yeah, they're like.
Especially if they're still alive, looking at you. Like,
Yeah.
right. So what we need to do, because when we've got, this is the ball bearing height, B drop height, is going to determine our GPE. All right? So what we need to say is, for our control experiment, we had a drop height of 0. Yes? Now GPE or EG equals mgh. Yeah? Neve, you didn't understand that?
No.
Have you never written energy or EP for potential energy? This is
Oh.
energy, this is gravity.
Yeah.
Yeah? So we're talking about GPE, gravitational potential energy, is a potential energy. All right? So writing EG means gravitational potential energy. Okay? Now we know that the mass is 100 grams. But this equation, what's wrong? You guys are going to have a fight. Is this too boring for you? I'm quite a boring teacher, I know. All right. She's falling asleep. Don't pretend. It's like she was yawning before as well. It's okay. I'm used to... You're coming hard at me now. Right. This is in kilograms. So what's 100 grams in kilograms? 0.1. 0.1 kilograms. Gravity on Earth, except for flow, is
9.8.
9.8 what?
Meters per second.
9 meters per second.
Minutes or meters?
9.8 meters per second per second. Okay?
What does per second mean?
It means every second you speed up by another 9.8 meters per second.
Oh, yeah, we did that.
That's good.
If we write meters per second to second instead of doing that.
You can write it as that, or you can write it as meters per second per second. It means the same thing. All right? Right. And then the height is what we're changing. Yep. Yeah? But for the control experiment, anything with a 0 in it, for the height, is going to make it all equal 0. Yeah? So at the GPE at 0, so we write here 0, 10, 20, 30, 40, 50. At 0, the GPE, or the EG, is also going to be 0. Right? Because anything times 0 is 0. Yeah? Yeah, yeah? No half yawns, ball bearing. What? What for? Martial arts? Huh? What? Underwater? You do martial arts underwater? Jeepers. Now 10. So here we would do, for 10, EG would be 10 times 9.8. Oh, sorry. That was 10 this height. So 0.1 for the mass. 0.1 times, but now it's 10 centimeters. What's 10 centimeters in meters? Because height's in meters. 10 centimeters. Sorry? 0.01?
0.001.
0.1. 10 centimeters. How many centimeters in a meter? 100. So 10 would be a tenth, yes? Times 0.1 equals. Anyone got a calculator? I don't know. You've got the calculator. Are you a human calculator? Flo's a human calculator.
Yeah.
0.098.
0.098. And what's the units? Joules. Capital J. Now, 20.
EG is gravitational potential energy.
Correct. EG. Now, if at 10 it was 0.098, now we're at 20, which is double 10, that would equal, what's 2 times that? Don't try and do it with a calculator.
0.196.
Is it? Did you do it in your calculator?
Yeah.
0.196.
Yeah, that's
Uh-huh. 196 joules.
Does 10 centimeters have less gravitational?
Yes, because it's lower.
than 0
The higher you get, the more stored energy you've got. What's wrong?
No, I get it.
I'm not very bright, so I can't follow. Right. Now this is 3 times that. So that one will be 0.294 joules.
It'll be
0.392 joules. 0.490 joules. Uh-huh. 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 You're supposed to go, uh-huh.
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 Okay? So now, going back to this, if we've got more GPE, it means we're going to have more kinetic energy just before it hits the sand, and we're going to get more movement of the sand, which will increase the depth. Shall I write that down for you in a slow progression of ideas?
Yes,
Yes,
Oh,
please.
uh-huh.
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 Okay. All right. Right. Now remember, this was your control experiment. It allowed us, gives us a baseline. We know now that without the independent variable, with no height, you get no depth in your crater. Okay? And we know that any result that we have here must be due to the increase in height because you've got lots of controlled variables, which makes it a valid experiment. What are you going to do? You're going to sneeze all over the back of Neve.
Please don't.
She sneezed all over the back of you.
That's not very nice.
Right, so over here, this is the progression of thought. Are you ready? If you increase height of ball drop, you can sneeze as well. No. Don't sneeze on Emily. She's a dominator. Just warning you. You go home and you've got one arm. Mum goes, Juliet, what happened? You've only got one arm. Oh, I sneezed on Emily and she snapped my arm off. She's been known to do it. Right. As the height of the ball drop increases, you increase the GPE, or we can write that as EG. Okay? And we work that out down here. Yes?
In our discussion, do we write our workings out?
Do we what?
Write our working out of.
You should do, because you're trying to explain what your...
Yeah. So we do those equations in the.
I would show the working that allows you to make a statement like this. Yes. So what? The trend was up here. As you increase height, you increase depth of crater. We're trying to explain why we get an increase in depth in crater now. This is the understanding for the depth in crater. Yep. So now we've got these results. I'm just writing down how we can then link our calculations back to this. Yep. So what you're doing now in your validation test, they'll ask you to calculate. They'll ask you about this. They'll ask you about the conversion of energy. They'll ask you about wasted energy. They'll talk about why does the sand move, etc. Okay. What we're trying to do is here get the best understanding of our results. Yep. So as we increase the height of the ball drop, we are increasing the GPE. So we're holding it higher and higher and higher. And as we hold it higher and higher and higher, it has more stored energy. And when we drop it, we get an increase in kinetic energy. Yes? And we know that the thing that we're measuring is this here. This is our useful result. Yep.
So when the balls drop, there's a decrease in potential energy and an
Increase in kinetic energy. Yep. All right. So then with the increase in kinetic energy, we're going to get an increase in the depth of the crater because of this. It's making the sand move. All right. Is it going to be a perfect conversion? No, because we're going to have wasted energy, heat, light, and sound. It's not going to be very much because when you drop a ball bearing on sand, it doesn't make a lot of sound. It doesn't release a lot of light, and it probably makes not very much heat. But you will get a little bit because of friction. So all of these ones here are there from friction. Okay? You will never get 100% conversion because friction is always involved whenever two things are rubbing against each other. In this case, it's the ball bearing rubbing on the sand. Okay? And then for the conclusion, we're going to say that my results support my hypothesis. Right? Because my hypothesis, remember, was this, and my results look like this. Yeah? So we're going to say my results support my hypothesis. Yeah?
Is that all you say?
Sorry?
Is that all you say?
That's all I would say. And you can put in, if you want to, you can think about some sources of error. All right? But the main sources of error are trying to make it less humans and more robots. The more technology you can put in there, the better it is. All right? Because humans always make mistakes. Most humans make mistakes. Most. You guys will make mistakes. If I was to do it, it would be perfect. Of course. And Emily. And maybe Sienna. And maybe Olivia. Maybe. Hi, Flo. Give me those evil eyes, Flo.
I have a good side eye.
Who, what? Oh, you're giving me side eye. Ooh. That's nasty.
I know. I'm quite good at it.
You are.
Yeah.
You've got RSE. Resting side eye. Means it just comes naturally. You can just go there.
I don't even have to move my head.
I know, that's good that you don't. Right. All good?
Yeah, thank you.
All right. Will you have fun?
Thank you, Mr. Brown.